4, find the tangent to the folium of Descartes, x cubed plus y cubed equals 6xy at 0.33. You'll notice some of these things that we're doing have special names. That's because some guy back in the day did it, and they made this. And this folium of Descartes, if I remember right,
What's his name?
yeah, it's René Descartes. He's the guy that came up with the Cartesian coordinate plane. We talked about him before.
Oh yeah.
I can't remember if it goes like this. Kind of makes a fish-looking thing, but I can't remember if it goes that direction or the other direction. Let's see. Flip, left, right. It goes one of those two directions. I can't remember, but it looks something like that. But you'll notice x cubed plus y cubed equals 6xy is the exact same problem we just did in problem 3, right? So we've already done its derivative. So we start off there. Dx, or dy over dx equals, and let me go 2 pages because I don't remember, 2y minus x squared over y squared minus 2x. So that's the derivative of that function. Again, we go through all that process to find a derivative like we normally do. Once we get to the point where we're trying to find the tangent to the folium of Descartes, and usually it says find the equation of the tangent line. They're getting a little lazy in their instructions in the book here, find the tangent, but that's finding the equation of the tangent line. We need to know the slope and the y-intercept of this curve. This is x and y. 3 and 3, they're the same. If we tried 3 and 3, 3 cubed is 27, 3 cubed is 27, that makes 54. 9 times 6 makes 54. That's a point on the curve. Right? So again, as long as it's equal, that any pairing of x and y that makes an equal statement on that equation represents a point on the curve. If I substitute y with 3 and x with 3 into this expression, I'm going to get 2 times 3 is 6, minus 3 squared is 9, over 3 squared is 9, minus 2 times 3 is 6. 6 minus 9 is negative 3, 9 minus 6 is positive 3. So we get a slope of negative 1. Again, slope is what it has been for the last like 4 or 5 weeks with derivatives. You find a first derivative, you substitute your x value in to find the slope when we did explicit functions. Now doing implicit functions that have both x's and y's in the derivative structure, we substitute both x and y into the derivative to find the slope of the tangent line. Then, if m equals negative 1, we're going to the point 33. Again, y equals mx plus b is always the structure of the equation of the line. Y is 3, m is negative 1, x is 3, and b is what we don't know. So 3 equals negative 3 plus b. So b therefore would equal positive 6. And that gets me to y equals negative 1x plus 6 would be the equation of the tangent line.
I like that.
And this is a situation where if I tried to put that graph into my calculator is not powerful enough to do that. Some more powerful calculators, like if you go onto Google and look up graphing calculator, they can, some graphing calculators allow you to put an implicit function in to graph. You just say graph that and it'll graph it. The TI-84 Plus needs a y equals. To get that down to y equals would be very challenging. Since there's a y to the third power and a y to the first power, it requires you to solve a cubic abstract equation. At one point in time I've done ones like that. I haven't done it in a while, so I don't remember specifics on how to do it. It wouldn't be very pleasant. It'd take about 3/4 to a whole page of paper. It wouldn't, get writer's cramp in your wrist and your elbow. So anyway, to actually graph this, if you really want to graph an implicit function, again, Google it on the computer, type in implicit graphing calculator, probably be what you want, and that should give you the ability to type in an implicit function. It should give you a graph, and then you type in this one too to see that they're tangent. You should see that happening. But again, with our TI-84 Plus calculators, it needs an explicit function, which would be difficult to make on it.